Okay, so today I'm going to be going over the respiratory system for three different types of phyla. First, I'm going to talk about the sea star, which is part of the phyla Echinodermata. And then I'm also going to talk about the mussel, which is part of the phyla Mollusca. So for these two organisms, I did put them on the same page, just so we can kind of compare and contrast. They are very similar in the aspect that they both use water for their means of gas exchange. So starting with the sea star, if we take a look at the picture that I have here on the left side, this is a picture of the sea star. And the sea star uses a water vascular system in order to perform its gas exchange. So what that means is that basically there's a network of vessels in the body of the sea star where water can get pushed through and it can just reach the different parts of the body. So if we look at this picture that I have, this is the backside of the starfish basically. And then obviously the opposite side would be the front. And on the front side, we have what are called tube feet. And you can kind of see them right here as this is kind of flipped over a little bit. These are the tube feet, and this right here is a blown up portion of it too. And these tube feet right here have little suction-like projections at the very end of them. And these allow the water to get sucked up through there, and then they'll go ahead and go through the radial canal, which is right over here. It just goes alongside this way and all the way up throughout the starfish, or sea star, sorry. So these little tube feet are what help the water get into the sea star, and once the water is in the radial canal, it then circulates the water throughout the body. And as the water is circulated, then the oxygen is taken in and the carbon dioxide can then get expelled through the tissues. So similar to the sea star, the mussel also does use water for its means of gas exchange. But what happens over here is the mussel basically uses water and it goes through this in-current siphon that we have right here. And this picture that we're looking at is a cross-section of the mussel where it looks like we cut it in half and now we're just looking down at it. So, as I was saying, the water goes in right here through this in-current siphon, and it goes across this portion called the mantle. And this whole cavity right here is the mantle, and that goes all the way up here and over here, and just surrounds basically the whole shell of the mussel, I guess you could say. So the water flows across the mantle, and then what's on the mantle are called gills, and these gills have cilia on them, and the gills are highly folded and highly vascular. So when the water goes through this portion right here and then it finally reaches the gills, the oxygen can then be exchanged, and then the water and the carbon dioxide will get pushed back out over here through this excurrent siphon that we have right here. So if we go to the next page, on this page I'm going to be talking about the earthworms, which is part of the phyla Annelida. This is a little bit different from the two organisms that we had previously talked about, just because it doesn't necessarily use water for its means of gas exchange. However, it doesn't have lungs either, just like those other two organisms didn't have lungs. So the earthworm has to do its gas exchange through the means of diffusion. So oxygen and carbon dioxide are able to pass through the earthworm's skin because the earthworm keeps its skin moist. And in order for that to happen, there's these pores and these ducts on the epidermis and the top surface of the worm's skin that help excrete body fluids and mucus and that's what keeps the earthworm moist. And if it wasn't kept moist, basically, then it wouldn't be able to go and do the gas exchanges that it needs in order to live. So just to recap, basically, sea stars use a water vascular system for their means of gas exchange. Mussels use gills to help with their gas exchange process, and earthworms go through the process of diffusion.